Hello everyone, I am Dino, together with Joseph and Ryan. We are back for another video presentation. Here today, we are going to show the procedure for panel data estimation. This is our panel data, and the sources primarily from ADB statistics. It comprises 7 Asian countries, namely South Korea, Philippines, China, Indonesia, Thailand, Vietnam, and Singapore. The variables we select are GDP, unemployment rate, inflation rate, government expenditure, and gross capital formation from the years 2000 to 2017. Let's begin now the procedures. First, we copy these figures and put them into this data. And then, we should allow data to acknowledge the dataset as panel data by commanding xtset and then country and year. Now, it is showing that the dataset is strongly balanced. Before doing the OLS, let's transform the variables into logarithmic form, excluding unemployment rate and inflation rate. Second, we command reg and then ylist and xlist for pooled ordinary least squares estimation. The GDP will be the dependent variable in ylist, and the rest, namely unemployment rate, inflation rate, government expenditure, and gross capital formation, will be the explanatory variables in xlist. Based on the results, the R squared is 6% and the adjusted R squared is 3%. Government expenditure, gross capital formation, unemployment rate, and inflation rate explains 3% of GDP in 7 Asian countries from years 2000 to 2017, ceteris paribus. Suspected that there could be a omitted variable bias since the adjusted R squared is very low. There could be a heterogeneity problem, and for that, we will address the issue using either fixed or random effect by using the Hussman's test. First, we will perform fixed effect regression by commanding xtreg, ylist, and xlist. And then FE. In this portion, only government expenditure is statistically significant determinant of GDP at 1% significance level. Next, we command estimates store fix. In order for data to record the figures. Next, we perform random effects regression by commanding xtreg, ylist, xlist. RE. In this portion again, only government expenditure is statistically significant determinant of GDP at 1% significance level. Next, we command estimates store random. And finally, we command Hussman fix random. To identify what effect must be used. In the analysis, use fixed effect if prob-chi is less than 0.05 or 5%. In this case, we will use random effect since the value of the prob-chi is 0.36 or 36% and it is comparatively bigger than 5%.
So we are done testing using the Hosman test for panel estimation. But we will not stop here because panel data will likely to be affected of the issues for serial correlation and heteroskedasticity. So if serial correlation and heteroskedasticity are not present in the panel data, whatever the result in the analysis of Hosman's test, that will be our final estimates, whether fixed or random estimates. But we need to run through the test for heteroskedasticity and serial correlation to check if they are present. So, to test for heteroskedasticity in panel data, we will use the IGLS, or the Iterated Generalized Least Square Regression. So, to begin with, step 1, type XDGLS. XDGLS. Then, our Y-list and X-list, which is the dependent and the independent variables. Comma, space, IGLS panels. Remember, this is heteroskedastic. Yep. Sir, there. Here you go. Step 2, estimates star hetero. There, estimates star hetero. So if you're asking, where did I get this? So I got this from the website, from the Stata website. So here, you can just copy paste all the codes here. These codes are for the data panel for testing heteroskedasticity and autocorrelation. So step 3 is this XDLGS. Same with the step 1 XDGLS. Are dependent, independent, and also comma IGLS only. Then hit enter. There. Fourth step is the local. Enter. And here's the last step, the LR test hetero. There. So after doing all these steps, so we can now proceed the next step for the testing for serial correlation or the autocorrelation. So the analysis for this is together with the analysis for autocorrelation using the wooldridge test.
Good day everyone. So at this moment we will test autocorrelation using wooldridge test. So first step is find it xt serial. So click here to install. Okay. So next step is just simply copy this command and also copy this one. So these steps are very relevant because we need to install first the packages in order to implement the wooldridge test for autocorrelation. Okay, so next steps is just encode xt serial y-list and our x-list. So xt serial y-list, which is gdp log, and our x-list. So analysis. A significant test statistics indicates the presence of serial correlation. So as we can see here, we can say that it is statistically significant at 10% level. So hetero and serial correlation is present.
Therefore, we will not use random effect as our final estimate. So, since hetero and serial correlation is present, we will proceed to step 5. We will use GEE population average model to address the problem. So we will just simply encode XTGEE, YList, XList, and comma core AR1 robust. So XTGEE. So this is our final estimate. Um, as we can notice, no statistical significant determinant in this final estimate since the figure are more than 10%. So yeah, this is our final estimate. Since we have problem of serial correlation, we cannot use random effect as our final estimate. So I hope you learned something from our discussion. Thank you for watching and God bless.